Okay, let's see if I can go on here without messing up. So I've got the range. I'm seeing if everything fits on my camera here. So I got the range, quartiles, and then what's called the 5-number summary. So we're talking about a distribution of a set of values, depending on what the distribution is about. Earlier we had one with apartments, the first problem, that gave us a 15 values, which is the distribution. If I wanted to find the range of those apartment prices there for the rent, I would take the ranges figured out by calculating the highest value minus the lowest value. And that is our range, quite simply. Our calculator doesn't give it to us explicitly, but we can do it from the 5-number summary when we get there. Alright, but for right now, that's what the range is, the highest minus the lowest. Quartiles are the values of the distribution that are broken up into 4 quarters, you may say. So something like this here, like in a 1, 2, 3, 4. Here's like a what's 4 quarters? Football games or basketball games, right? Quarter 1, quarter 2, quarter 3, quarter 4. All right. So we've got the quartiles, which was what they're called. All right. And the quartile. Let's see. Where can we start here? Here's the one in the middle here is the median. This is the median of all the values. The one in the middle here. That would be our median of all of them. All the values. This line here would be our upper quartile, or sometimes called the 3rd quartile. All right, let's call this upper quartile. And how is that found? That is found by the median of the highest value and the median itself, the overall median. So that's the median, I guess the median of the high and the median itself. And the median itself. That's how we can calculate that. This is manually now too. This is kind of cool because we're doing this on the calculator. So we're not computing these all together, but I do want you to know the background of it, where it comes from. So this is the upper quartile. This is the lower quartile here. Lower quartile or quartile 1. And how is that determined? That's determined by the median, or I should say it's determined by the median of the median and the low value. So this is our low value, and this is the median here. So it's the median of the median and the low value. Okay, I hope that's understood. And again, that's written out nicely in our textbook after the range, where it's talking about the quartiles in the 5-number summary, which is on page 375. Page 375. Okay, read that over well, and that'll say the same thing I am. I'm trying to anyway. 5-number summary. Well, this depicts the 5-number summary here in our quartile range. We've got a high value. I'll write it in the order that it's given. So if I have a line here, this is the high value, and then I have the upper quartile. What's next? The median. Extend my line here. This is the lower quartile. Lower quartile. And this number here was the low value. So therefore we've got 1, 2, 3, 4, 5. And this is our 5-number summary coming from these numbers here. Okay, what did I do here? Let's see if I can muster my way through. Okay. Number 11. What are the quartiles of a distribution? How do we find them? What are the quartiles of a distribution? So the answer to that is B. The quartiles are values that divide the data distribution into quarters. That's this way here. You know, quarter 1, 2, 3, 4. Even though there's 5, lines that I have going up, it's 4 sections. How do we find them? The answer to that is, after you read through all this, which is just, like, whoa, the answer comes out to be D. The lower quartile is the median of the data values in the lower half of the data set. Boy, do I like the way they said that, more than how I said it. The middle quartile is the overall median, okay? And then the upper quartile is the median of the data values in the upper half of the data set. Okay? So, nicely put, concise and to the point. Let's see, I've got number 12. Decide whether the following statement makes sense or does not make sense. Explain your reasoning. The standard deviation for the heights of a group of 5-year-old children is smaller than the standard deviation for the heights of a group of children who range in age from 3 to 15. Okay, I got to take a time out, erase the board, and I want to talk about standard deviation next. Okay, that's another term that they are bringing up at this point.